Hey, welcome everybody. Hope everybody had a very nice Christmas and Happy New Year coming up. In this quick video, what I want to do is I'm going to go through kind of understanding what web programming is, and I want to talk about middle tier, front end or UI type programming, what that means, and then kind of the back end or the database or wherever the data structure is. Talk about that. I also want to talk about what a database data structure consists of, a CRUD database, and talk about what that is. And then compare that with a blockchain. And then I want to talk about what kinds of blockchains we have, public and private, open and closed, and then talk about how a hybrid approach would work. And really, it's probably the approach that most of us should probably take when we think about a blockchain solution that we want to implement in our existing environment. So hopefully that makes sense. And so let's go ahead and get started. All right, so the first thing I want to do is let's just not even consider anything blockchain specifically. But what we're going to do is we're just going to kind of look at a logical layout of what we would consider kind of what a full stack architecture might look like. So in a full stack architecture, we have this back end that kind of holds the core data. And many times in a back-end architecture, this back-end is going to be what we call an RDBMS, and that stands for Relational Database Management System, or simply a database. And so what that database does is it holds a lot of different data tables, and it organizes them in such a way so that we don't have things like redundancy. So that, for instance, if you're storing my address, you're really only storing it in one place, and that one place is then referenced by all the other places. And so, in essence, it creates a lot of efficiency in data storage, but it doesn't necessarily worry about what we would consider immutability. And I'll talk more about that here in a little bit. All right, so that's kind of what we would consider a back end, or the back end portion of any web application. And so usually we consider, or we communicate with this through what we would consider a query, meaning that we're asking those data tables to give us something. So we usually use things called select statements to do this, where we'll say, hey, give me or select from let's say the student table, students A, B, and C, and then give me their first names and last names. And so, select first and last from student table where student is in this class, right? So then it would come back with a list of students that are enrolled in a particular class, give me their first and last name. So anyway, that's just in essence what we call a query, but usually that's using, like I just said, kind of a select statement. Sometimes we'll do an update where we can update data in that database. Maybe we can delete data in that database or remove data in that database. And we can also read or select data. So we're creating data or doing an insert. We're doing a select or a read. We're doing an update, and we're doing a delete. So that's what we consider a CRUD database. And we use what we call SQL usually in order to communicate with this database. And so we're going to put CRUD there. And so what that means is again, we can do a create, read, update, and delete. And so that's really important, because what that gives us the ability to do is it gives us the ability to normalize that data and make sure that data is very efficient so that it's fast and readable, and it gives us a lot of performance. And so databases are notorious for, or not notorious, but they're very, one of their big accolades is that they do give great performance. And so blockchains really don't compete well with that. Unless we're just looking at multi-unit, or since we have multiple instances of the data, we can read from it pretty quickly. So anyway, we'll talk more about that when we get into performance comparisons. All right, so that's the when we think about a full stack web application, that's kind of the back end portion, or where we're storing our data is a lot of times in a database. And then many times what we'll have is we'll have kind of this middle tier. And I'll put this in a different color here. We'll put this in a blue color here. And so this middle tier is where we're going to put in kind of what we would consider our business logic, right? So this is going to be, in essence, this is going to be kind of like our business rules, or this is going to be the rules that we put in place to say, here is the structure that defines how we're going to do things. So that might be how we're going to source our supplies in order to make our product. That might be how we're going to price our products in the store and how we do our accounting. That might be how we pay our vendors. That might be how we track and trace benefits for employees. It could be a myriad of things, but in essence, it's just simply the logic that defines how we're going to do business. And so a lot of times that's really important, and so we need to protect that information, right? And so a lot of times what we do is we use code to protect that, right? And so, that code might be various different types of languages. And so, you could be using Java, maybe JavaScript, maybe some Python, or some Go, or some R, or some React. But in essence, maybe there's some Angular JavaScript in there. But in essence, what you're doing is you're simply defining, when the data comes in, you need to format it, you need to do something with that data, you need to check certain things, you need to do things with that data before you submit it to the database for read and write operations, right? And so it's important to understand that, because that's basically where you kind of lay out that business logic, and that's where you put that business logic into place. And so then out here on the front end, so let's go ahead and put this in green. And then out here, so remember, this is all logical, right? This is just kind of logical. These boxes don't simply represent physical locations, or they could, but just depending on the application. So, all right, so then out here in the front end, this is where we have our web server, right? And so this is like, this is what I would consider kind of like the UI, or the user interface, right? And so this is where we think about, how are we going to format this data, right? So, what's the HTML5 going to look like? What's the, sometimes we might have some JavaScript maybe that's being used here for formatting the data from time to time, but a lot of times that JavaScript is also doing business logic. So you might have JavaScript that's in your DOM model, which is your basically how they're laying out the form that you're reading in your web browser. So you got your HTML, and then you also have this thing called CSS3. And in essence, what that does is that stands for Cascading Style Sheet version 3. In essence, what it does is it basically just kind of encapsulates data with styling based on the data object, and defines kind of where that data is going to be, what it's going to look like, and stuff like that. So if somebody says that they're kind of a front-end web developer or a UI developer, a lot of times that's kind of what they're doing for us, right? So they're just kind of developing how something's going to look and feel for us, but not necessarily like data modeling or maybe even the business logic that we would find in that middle tier. Okay, so now that we understand the basics of that, and we kind of understand kind of what a full stack web developer would be, and we also learned, and so again, the UI, the HTML, business logic. Okay, so this is kind of the traditional model that we've been using. And so then a client would just connect, with their browser or whatever. They would connect to this web server, and then it would go through the business logic, retrieve the data, format it, give it back to the user, right? So that's in essence how we protect our stuff. A lot of times we might even stick a firewall here. So, we'll put a firewall right here, and we only let people in through port 80 or something like that to our web server, or maybe if we have secured sockets, maybe we use in port 443 or something like that. But anyway, that's in essence how you kind of protect these servers. But basically that's what's going on, right? So all right, so let's take a step back and let's evaluate a couple of things here. So in essence, important things to remember here is that really the endpoints, so, when we're writing data in, right, so the data has to come in, it has to be stored here, but we're only allowing people in through here, and nobody really is going to have access to this. So we're really protecting our business logic quite a bit. And that's really kind of traditionally, from an architecture standpoint, that's really what we want to do. We don't really want that information to be out there. So if we think about, where is this going today, or how's this going to look like in the world of the future, and then we'll take a step back and just kind of look at the blockchain piece. So when we think about how we're going to move in the future, a lot of this stuff that we see out here on this database is going to move over to another type of data model, which we would call a blockchain, right? And so let's see, what would be a good representation of a blockchain? I guess we'll just do a block, a set of blocks here. So a blockchain, so if we have a chain of blocks here, and so let's just say that's my blockchain, and we'll encapsulate it in a nice little data model here. And we'll say this is our blockchain. Okay, and so when we think about a blockchain, the difference between a blockchain and a database is that a blockchain is still going to be storing data. You're still going to be able to read data from that blockchain after you've stored it there. So obviously you can write data to it or create data and read data, but there's no UD, right? So remember the create, read, update, and delete? There's no update and there's no delete. Could you make a change to something that's already there? No, but you could make a new line that says that that value has changed. You could do that. And so it's very much like what you would see in like a balance sheet, right? Like a balance sheet that you might have from the bank, right? So it shows your deposits and it shows your withdrawals and it shows the balance and it shows everything that's in there. And so in blockchain, we actually call that triple entry accounting because not only does it show, it shows the credit and it shows the debit, but it also shows what we call the key, which in essence it's just to zero, right? So it's just all the transactions that correspond to those credits and debits all the way back to zero. So you can see kind of how that math works out from its inception. So that's where we get like a lot of track and traceability for things like supply chain objects and things like that, because we can see kind of everything that's happened with that orange from the time it was picked or from the time it was actually planted or whatever the particular produce is. So that's where like Walmart's doing a lot of cool stuff with track and traceability and stuff like that, because with a blockchain it actually keeps track of every aspect and everything that goes on with a particular object all the way back to zero. So that's really cool stuff, and it does a timestamp on it too. All right, so that's so anyway, that's triple entry accounting. If you're curious on what that is, it's basically, again, it's just your credit debit that we're normally used to, but it's also adding another key, a unique key that's tracking that transaction back to zero and also validating that that transaction is good. So that's another cool aspect of triple entry. So I'll do another video specifically on triple entry so you guys get a better understanding of it. All right, so back end, important thing to remember here is that blockchain is using a database or a data structure just like a database did, but in this instance, there's really only read and write operations, and so those are the only things that you can do with the blockchain. So keep that in mind. And another key aspect of the blockchain is that the data, because of the way that we talked about the hashes and then how we hash the previous and the next block in the block header, so that gives us what we call immutability, so that if you change the block after it gets up to a certain block height, then it's almost impossible to change the block down here because of the cost involved, right, with the multiple nodes. So having multiple nodes and also having those blocks chained together is what gives you the security and the immutability, because you can't make the change in all of those places at the same time, and so it causes you just can't do it. So that's where you get the immutability through the cryptographic hashes. And so hopefully that makes sense. If you need to ask more questions to me, feel free to reach out to me on that. All right, so that's the immutable ability that we have here at the blockchain level. And so then our business logic, this is where we have these things that we call smart contracts that come into play, but we can also still use. Now there's a big misconception, because a lot of people think that, if we're using smart contracts on a public chain, that somehow that smart contract is going to be exposed. But that isn't exactly, I mean, I guess it is true if you're thinking about a public chain, but if you're thinking about a private blockchain, you can still use Java and JavaScript in your own internal environment before you even submit anything to the blockchain. So before you even submit anything to the smart contract, you can obfuscate that data, you can strip that data or scrub that data for whatever identifying characteristics before you write it to the blockchain. You can encrypt it to make it a hash before you actually write it to the chain, so that you're really only indexing the hashed data, so you're just using a pointer to what's on the database so that you can prove that at a particular point in time this was the status of the data. But there's a lot of things that you can do there to kind of just layer this out. So instead of having 3 layers, now maybe we might have 4 layers, right? And so, the blockchain is where we're actually storing maybe just the transactional data that's actually still up here in the database, right? So the data is still here in the database, the specifics, but we hash the transaction, write the key of that hash, or the digest of that hash to the blockchain, and that gives us the immutability, and then we can just prove that, hey, that was the transaction that occurred, and we can prove that nobody did anything with that transaction, and that it's not been tampered with. So in essence, you can build out the solution that is what we would consider a hybrid solution, where we're not specifically dealing with just a database or just a blockchain, we're dealing with both, right? Because a lot of the data that we're writing has to have the ability to change, right? And so if it does need that ability to change, then we may need to just define what was the status of your transactional data at a specific point in time, and then just simply write that into the blockchain and then let you own that transactional data. So hopefully that makes sense. And if you want to learn more about that, I'll be happy to talk to you about how these solutions might work. So anyway, that's kind of what we have here in this middle tier. Is we have either, we can still have this business logic that comes into play that's still going to do all that business logic and tie back into it. And then we can also tie in smart contracts that do kind of a final formatting of the data before we actually write it out into the blockchain. So the smart contract might be responsible for, just checking or checking conditions and ensuring that the conditions are right for auto execution of what's in that smart contract. Because one of the things that we want to remember about a blockchain is it is read and writable and it's immutable. But another thing about a blockchain that makes it very desirable over a database is it's not centralized, right? So it's decentralized, meaning that multiple parties have the ability to write to that database. And so that's important, or write to this blockchain. And so when you have a blockchain, no particular party is responsible for all of the management of that particular object. You're allowing that object to be decentralized amongst multiple parties and then decentralizing the data. In a private blockchain, what you can do is you can go in and then set up an access control list that defines the level of permissions that a particular individual might have once they've met the qualifications to meet that role, right? So that role might be that they have the ability to write medical records to a medical chain, but they can only do that if they're part of a medical network that's been proven through some type of quantifiable smart contract. So you might have a smart contract there that allows people into the chain to start writing. So that's what we would do in more of a private environment like Hyperledger or Corda or something along those lines. All right, so in essence, then we would still have the same user interface, still have the same HTML, all that stuff. The only thing that's really changing, again, when we're thinking about a blockchain, is we're just adding in these smart contract layer that just kind of allows us to kind of format that data or do something with that data or do auto execution of something, so that we can ensure that things happen automatically based on certain conditions. And so those conditions, or the input of that data as it comes in through the user interface, can be all done through the same old business logic that we used before. We just can then now do auto execution of conditions and tracking and tracing of conditions. We can use things like IoT devices to check those conditions, to ensure things, to make sure that things are at certain temperatures, to make sure that we get certain counts, and then pass that data to an oracle that then can be used in the smart contract in order to read that data in. So I'll talk more about that in a couple other videos later on. We'll talk about IoT and how to use oracles, how to tie that back into your smart contract so you can use it in your full blockchain solution. All right, so hopefully that makes sense. So my thought is that I think that probably where we're headed right now, we see this blockchain sitting here in the back end that's kind of replacing some of this transactional data. So this, again, would be what I would consider a hybrid solution, because what we're doing is we're mixing a database and a blockchain solution. And then, at the middle layer, right now we're using just kind of our written out logic or whatever we want to put in here. But I think that probably as we move towards Web 3.0, This is going to become, machine learning and AI and stuff like that, where we can write logic in place that will understand plain English and questions that might come in from a user to interface with our data that's back here in the back end. So this user, how are we going to change their interface? Well, right now, the input is like thumbs, right? A lot of times people are using their phones all the time, or maybe they have a keyboard and they're typing their interface in. But, what's a much better user interface that we're seeing a lot of people catch traction with today is alternate reality, things like virtual reality, alternate reality, stuff like that. So anyway, I think that's probably where we're headed. As far as the user interface is concerned, it's going to be maybe an AR to virtual reality. Or we're going to be able to input data much quicker and easier, other than just using our thumbs. Voice recognition is becoming very quickly catching traction, stuff like that. So anyway, hopefully that makes sense. But I think that's where we're headed. So anyway, I got off on a tangent there. So I didn't really talk much about public and private networks. So and open and closed. So what does this all mean, right? So when we think about public blockchains versus private blockchains, right? So I just want to make this really clear on what I consider public blockchain and what I consider private blockchain. A public blockchain means simply that. That means that it's publicly available. Anybody can join the network, and anybody can start writing data to the network as long as they own coins in that network, right? So anybody can join, everybody's welcome, everybody can jump in, right? So we see that with things like Ethereum, we see it with Bitcoin, we see it with Status and Lisk, and so on and so forth. They're public blockchains, right? So a lot of those public blockchains, basically do a lot of the same things. They just have different features. So if you want me to take a look at a white paper or something like that, just let me know, and I'll tell you a little bit about what the features are of that particular blockchain and what makes it special, or what its niche is. But in essence, what it's supposed to do, any blockchain should provide some sort of decentralization. It should provide encryption of the blocks, and it should chain those blocks together so that there's immutability in the data. And so that's what you're going to be looking for. And then a private blockchain would be more of a blockchain where not everybody has the ability to join in and just start writing data to the chain, right? Because remember, in a public blockchain, anybody can go in and write data to the chain. And then also, if you're joined into a public chain like Ethereum or Neo or something along those lines, you're plugged into one of those chains, then you're actually, if you're plugged into that chain, you're not only are you writing to your data to that chain with no rights that were predetermined, or you weren't qualified by it for anything in order to join that network, but also you have the ability to read everything, right? So there's some type of a block explorer that allows you to read the data that's there, that's been written to chains. And so if you are on a private chain, then you can still read the data, but you can only read data that you have permissions for. So it's more permission-based, where you have been given a set of rights, and then you have only the rights that you have been given. And it's not open for everybody to read and write to. So when we think about public and private networks, we're thinking about the writability. So if not everybody has the ability to write, then it's probably a private network. Open and closed, we're talking about the readability. So does everybody have the ability to read? Then it's open. If it's closed, then that means that only certain people have the ability to read. So if you and there's a mixture of that. So you might have public open, which means that everybody has the ability to write and everybody has the ability to read. And that's what we would see with like Ethereum or Bitcoin. But you might have an application that might be public closed. So as an example for that might be, everybody has the ability to go in and write data, but only certain people have the ability to read that data. So as an example, that might be a voting application where everybody has the ability to go in and vote, but only the voting administrator or whoever's responsible for collecting those votes has the ability to read those votes that came in from the public. Maybe you have a private open where only certain people have the ability to write, but then everybody can read it, right? So that's what I think we might need to have with like federal budgets, right? So the federal government only has the ability to write their budget or write what's going on with their budget and the accounting information, but anybody should be able to go in and read that information and see where their money's being spent. Maybe a private closed network would be, where only certain individuals have the ability to see certain things, and only certain individuals have the ability to write certain things. So completely private kind of network. So anyway, that's what I consider, public and private networks. It really all has to do with, who has the ability to read, who has the ability to write, and then how do you want to architect that network around that functionality. So anyway, I talk a lot about mostly just about the general layout of what a network might look like, and then what this hybrid approach might look like when we start building out these solutions. So a great example of this, when I look at my history, I think about what are some things that need to be immutable, and what are some things that we need to ensure that we can make sure that the data is immutable and that it hasn't changed, stuff like that. Well, obviously those would be things like log files and stuff like that, to ensure that nobody's tampering with our log files, and that ensures that our data is good. So you might think about just throwing your log files out onto an immutable ledger, just to have a beginning starting point for immutability and start to play around with blockchain. So anyway, that's really all I have for you. If you have any questions, if you want to reach out to me, my email address is down there. I am a Bockchain Solutions architect, and I'd be happy to help you map out a solution for whatever blockchain problems you might be running into, or if you want to try to look to possibly using blockchain as a solution for something that you are trying to build out. I'd love to show you Microsoft Azure's Workbench, or if you want to look at the cloud templates that are on Amazon, I'd like to help you with some of those. Or if you want to look at an Ethereum network that maybe even want to take Ethereum and put it into your behind your firewall, just simply fork it, download it from GitHub, stick it inside your firewall, and then just use really a public blockchain, but use it privately inside of your network, and you want to take advantage of some of its functionality, you can do that too. So there's a lot of options that are available to you. Don't get locked down and think that you have to throw all your stuff out onto a public chain, or that you have to have everything in a private chain. I mean, there's a lot of different options that are available to you, and there's a lot of projects out there that make these options come pretty easily. So anyway, if you have any questions, please feel free to reach out to me. I hope you enjoyed this quick video, and I hope it was informative. Hope everybody has a great new year, and stay healthy. I hope you have miles and miles of smiles, and be good, my friends. Take care.